Hi friends, in this video I will tell you about profile and cross-section leveling. These are the instruments that are required to perform this activity. Auto level with accessories, the measuring tape, packs and leveling staff. These are some important terms that you must know to perform leveling. The first one is benchmark, reduce level, foresight, backside, line of sight and height of instrument. I will start with datum. Datum is an arbitrary level surface from which elevation of point may be referred. You can call it as 0 or origin. The next one is benchmark. Benchmark is a fixed reference point of known elevation with respect to datum. It is the only known point before leveling. The next one is reduced level. It is the height or depth of any point above or below any datum. So here RL of benchmark is from here to here. Reduced level of benchmark. This one. The next one are backside, foresight and intermediate sight. Backside is the staff rating at known elevation. This one. Foresight is the last staff rating. The intermediate sight can be the staff rating at a point where elevation is to be determined. The next one is line of sight, line of collimation. Line of collimation is the line joining the intersection of your diaphragm crosshairs and the optical center of object. Okay, this is the height of instrument. Height of instrument can be defined as the elevation of line of collimation with respect to datum. Okay, so from here to here it is height of instrument and this is the line of collimation or line of sight. So we'll start with profile leveling. In profile leveling, the idea is to determine the undulation of a ground surface along alignment. It is used for taking levels along the center line that can be of any alignment like road, railway canal or anything. So the center line is must and we have to level that. It can be the leveling can be done in two methods, that are height of instrument method and rise and fall method. In height of instrument method, these are the formula which you need not to memorize because if you know the terms you can easily understood these formula. The main idea here is like finding the height of instrument and subtracting the subsequent intermediate side readings from that height of instrument or from that line of collimation. The next one is rise and fall method. In this method, the idea is like taking the backside of the previous known stuff and subtracting the intermediate side of subsequent readings. Okay, so it is a typical example of leveling problem. Here what we do is like it is a road or anything. This is the center line, so we'll place our staff along this line. First of all, we place the auto level or set up our auto level, set up our instrument at a point which is very near to our benchmark. We take the benchmark reading as 100 or 50 in our case, and we'll take the backside to get the height of instrument. Subsequently, we will do for the points till the next point is not visible. After that, we will shift the instrument from here to here and take the subsequent reading. So here is an example. So what we do here is like that. First we stand at A, and it was the benchmark. So we have taken the backside reading. The backside reading is here taken as 2.510. We here take RL of benchmark as 100. You can take it as any other value. So the line of sight can be determined as the backside plus RL of benchmark. Okay, here it is done in the same way. RL is determined by the RL of benchmark plus the backside. Okay, so this is RL of LOS. So the idea is what, like we are subtracting the intermediate side from this LOS till it is not visible. Okay, so we have taken the IS as 3.105, 2.715, 2.910. So we are going to subtract these values from these to get the RL of that particular point. So we subtract this from this to get RL of B, this from this to get RL of C, this from this to get RL of D. So what happened at E is like we were not able to see the E point, so we shifted our instrument to that point, and again we have to take the backside reading. The backside reading here is taken as 2.710, and the foresight reading is taken as 4.125. That is the head reading. So how we find the RL of LOS? RL of LOS can be found like uh, adding the RL of previous point to the backside of this point, like RL of previous point to the backside of this point. Okay, so here we had find 99.6 plus 2.710, that is 102.31. So this became the RL of means reduced level of this line of sight. This is the RL of this line. So what we are going to do further is subtracting the intermediate side from this RL of this LOS. This was the foresight, so we subtract this foresight from this RL, not this RL. This was the RL for the previous setup. So we subtract this from this to get the RL of this. This can be done in the next method, which is rise and fall method. In rise and fall method, the idea is like that: we take the backside reading of 1 and subtract the intermediate side, and if it is negative, then it will be rise, otherwise it will be fall. Means if the lower reading is positive, then there will be fall. If the upper reading is greater, then there will be rise. So here what we do is like we have taken the RL of benchmark as 100, and we took backside at point A, that is 0.9. We had gone to B point, there the intermediate side was 1.1. So clearly there is a fall or rise in this value. We are going to calculate this rise and fall. So as intermediate side is greater than back side, so we can conclude that there is a fall, and this was 0.2. We subtract directly this from this. If we get minus, we'll call it as fall. If we get plus, we will call it as rise. So what we do is like we know the RL of A and we know the fall. If the value has fallen, so the RL of B will be this one. What we do at our next point is like that. We had shifted our point to point E, so we again had to take backside, and we'll subtract this value. This value I had got due to the D point here. I would have got the foresight, and I had subtracted this from this to get the rise, and that's why I had calculated RL as 99.85. So after this point, what happened is like you do the same process. Backside of this point minus IS of this point will give you rise or fall. What happened here was like here we had taken BS and FS both, and we subtract IS from FS. It was in the case of change point. So the result of the profile level can be plotted like this. Here we got the profile. So the next one is cross sectioning. Cross section are lines of level or short profiles made perpendicular to the center line of the project. The idea is that at regular intervals the perpendicular lines to the center line are drawn, and we find the elevation of this point and point in this line also. We have to calculate at least 1, 2 and 3 points in this profile. This is a profile and this was the center line, and we had taken this as the profile. So we had to calculate the level of this and along this line also. So it's an example like this was the center line and these are the cross drawn. So we have to take levels at these points along with the center line. So here is an example as how we have done. We took the instrument at position A as usual and took the back side, and RL here it's again considered as 100, and we took the IS at B, B1, B2, B3, B4. This is B1, B2, B3 and B4. This question has been solved with the method of rise and fall. So we are going to subtract back side to intermediate side and get fall. So we will subtract this fall from the RL of benchmark to get the RL of B point. Same way we can get the RL of B1 point. Same way we can get the RL of B2 point. Same way we can get the RL of B3 point. Same way we can get the RL of B4 point. What happened at E point is like that, we were not able to see it, so we considered it as change point, and again we had to take back side. So we had taken back side as 1.15, so and forward side was 1.885. Okay, so what we have done here is like this IS minus this forward side will give you the rise or the fall, and then next rise or fall can be determined by this back side minus the intermediate side of the subsequent points. Here we had find the this is a very good example to show you the difference between rise and fall. Here what happened was like value was 1.475, it has jumped to 1.480, means there was a fall. So we had written is at 0.01, as the lower value was greater, so we had considered it as fall. Here what happened was like it is like a reverse order of previous one, so we had taken it as rise. The intermediate side first fall was 1.48, now it is for 1.475, so it now became 99.34. In the same way the RL of these can be done. Please the result of this leveling can be the cross section of the road at every 5 interval is plotted on graph paper. Thank you a lot. The comment section is waiting for the reviews.